Day 380 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2901, longest unequal adjacent group subsequence 2. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string array words and then array groups, both arrays having length n. The Hamming distance between the two strings of equal length is the number of positions at which the corresponding characters are different. You need to select the longest subsequence from an array of indices 0, 1, all the way up to n-1, such that the subsequence denotes as I of 0, I of 1, all the way up to I of k minus 1, having length k. The following holds. For adjacent indices in the subsequence, their corresponding groups are unequal, i.e. groups of ij does not equal groups of ij plus 1 for each j where 0 is less than j plus 1 is less than k. Words of ij and words of ij plus 1 are equal in length, and the Hamming distance between them is 1, where 0 is less than j plus 1 is less than k for all indices in the subsequence. We turn a string array containing the words corresponding to the indices in order in the selected subsequence. If there are multiple answers, return any of them. Note, strings and words may be unequal in length. All right, y'all, so I can understand how that is a little bit confusing. So let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input words equals an array of strings BAB, DAB, and CAB. Groups equal an array of integers 1, 2, and 2. The output is an array of strings BAB and CAB. The explanation, a subsequence that can be created is indices 0 and 2. Groups of 0 does not equal groups of 2. Words of 0.length is equal to words of 2.length, and the Hamming distance between them is 1. So a valid answer is words of 0, words of 2, which equals an array of an array of strings BAB and CAB. Another subsequence that can be selected is indices 0 and 1, where groups 0 does not equal groups of 1. Words of 0.length is equal to words of 1.length, and the Hamming distance between them is 1. So another valid answer is words of 0, words of 1, which is equal to BAB, or an array of strings BAB and DAB. It can be shown that the length of the longest subsequence indices that satisfies the conditions is 2. So let's break this down one step further so we can really understand what's going on in this question and these examples. So first thing we need to remember there are 3 rules that we need to keep in mind, right? So the first rule is for adjacent indices in the subsequence, their corresponding groups are unequal. So the groups have to be the corresponding groups have to be unequal. Now let's break down what that means. So in this array of integers groups, you see how 1 is not equal to 2. So we can use these corresponding indices, right? But 2 is equal to 2. So we can't use these corresponding indices because in this case, the group's indices are equal. We can't use 1 and 2. We can't use indices 1 and 2, but we can use indices 0 and 1, and we can use indices 0 and 2. That's how we got 2 valid answers. But that's just one rule we have to worry about. The next rule is words of I and words of j are equal in length. So words have to be equal. That's the second rule right there, the word in length. Excuse me. That's the second rule right there. The words have to be equal in length. So as you can see, BAB and CAB have the same length. They both have 3 characters, so they pass that rule. Now the third and final rule is the Hamming distance between them has to be 1. Now what the Hamming distance means is one of these characters have to be different, right? So in this case, this B and BAB, this B is different than this C and CAB, right? So that has this Hamming difference of 1. Similar to the second output, which is BAB and DAB, that also has a Hamming difference of 1, right? Because this B is different than this D. So now that we understand, let me type that over here. Hamming difference equals the 1. So these are the 3 rules that we have to follow right here. So now that we know and understand the rules, let's go ahead through this explanation again so we can see that these rules are being followed. So we can see in the output that BAB so the corresponding index is BAB, that corresponds to 1, and then CAB, that corresponds to 2. So 1 is not equal to 2, that passes the first rule. Boom. Then the second rule, words have to be equal in length. So we can see BAB has 3 characters, CAB has 3 characters. So it passes that rule. Boom. Second rule, done. Hamming difference has to be equal to 1. As we can see in BAB, this B is different than this C and CAB. So it passes this third rule right here. And since it passes all 3 rules, then the output is an array of strings BAB and CAB. Similar to the other valid answer, we could go through this as well just to really make it make sense. So the other valid answer is words at index 0 and words at index 1, which is BAB and DAB. So when we look at the corresponding groups, they are unequal. The corresponding groups are 1 and 2. 1 is not equal to 2, so it passes that rule. Words have to be equal in length. BAB has 3 characters. DAB has 3 characters. Passes that rule. The Hamming difference has to be equal to 1. The B, once again, and this BAB is different than the D and DAB, right? So it has 1 character change, a B to a D. So it passes the Hamming difference rule, and then it passes, so this output as well passes all 3 rules. That's why we have 2 valid outputs that we can choose from. Now let's go ahead and take a look at example 2, where example 2 is a little bit simpler, right? So in example 2, we have the input words equals an array of integers A, B, C, and D. Groups equals 1, 2, 3, and 4. The output is A, B, C, and D. Explanation says we can select the subsequence indexes 0, 1, 2, and 3. It satisfies both conditions. Hence, the answer is words of 0, words of 1, words of 2, and words of 3, which equals A, B, C, and D. It has the longest length among all subsequences of indices that satisfy the conditions. Hence, it is the only answer. So once again, you can see by looking at these rules that we have to follow over here, the corresponding groups have to be unequal. So 1 is not equal to 2, 2 is not equal to 3, and 3 is not equal to 4. All of the elements and groups are unequal to each other, so it passes that rule. Then it says the words have to be equal in length. So each one of these words or each one of these strings has a 1 character, right? A is 1 character, B is 1 character, C is 1 character, D is 1 character. So it passes this rule. They all are equal in length. Then the Hamming difference has to be equal to 1. So since it's only 1 character, that means they need to be all different characters, and A is different than B, B is different than C, and C is different than D, and so on. They're all different from each other, so it passes this rule as well. And since they pass all 3 rules, we can return the whole array, an array of strings A, B, C, and D. Now, I hope that made sense to y'all, because now it's time to get into the fun part, the actual solution. Solution is definitely easier to understand than the question. Now, first thing we're going to do, right, we might as well do this first. We're going to create our helper function, which is going to compute the Hamming distance between the words at index I and index J. So for that, we could just declare, say, func. We could call it ham, open up the parentheses. We're going to say underscore I, colon, that's going to be an integer. Then we're going to say comma. Then we're going to say underscore J, colon, that's going to be an integer as well. We're going to come outside of these parentheses, and it's going to return an integer. Boom. Now, we're going to say let, open up the parentheses, we're going to say S comma T, come outside those parentheses, we're going to say equal W square bracket I, or excuse me, inside parentheses, so we're going to say parentheses W square bracket I, still inside those parentheses, we're going to say comma W square bracket J. Now, let's, before we get to moving too fast, let's declare the W's first. So first we're going to say let N equal words dot count. That's going to get us the words dot count. Then we're going to say let W equal words dot map, open up the brackets, and we're going to say an array, open up the parentheses, $0 dot UTF-8. And what that's going to do for W is going to convert each word into an array of UTF-8 bytes, which is going to help us with the comparison, with the character comparison. Boom. So now we can come back to our helper function now that we have declared W. And now we can say if S dot count does not equal, so exclamation point equal T dot count, boom, what we're going to do is we're going to open up the brackets and we are going to return dot max. Boom, just like that. Now we're going to come underneath this and we are going to say return. So first of all, this right here, this is going to, if the lengths differ, that means we can't compute the distance properly, right? So that's just going to make sure the lengths do not differ. Then we need to count the differing characters, or the characters that are not the same. So we can say return S dot indices dot count, open up the brackets, we're going to say S square bracket $0. Then we're going to say come outside the square bracket, exclamation point equals T square bracket $0. And once again, that's going to make sure that the characters are not the same, which is what we need for our Hamming difference. Now we can get back into the main function and we're going to create a dynamic programming tuple. So for that, we're going to say let, excuse me, not let, it's going to be a variable. We're going to say var dp equals, we're going to open up the square brackets, open up the parentheses, we're going to say len colon length, oh excuse me, that's short for length, but that's going to be an integer. Then we're going to say comma prev colon, that's going to be an integer as well. Come outside the square bracket, we're going to open up more parentheses and we're going to say repeating colon, open up parentheses, 1 comma -1. Come outside of those parentheses, but still inside the other parentheses, we're going to say comma count colon n. So len, what len is going to do right here, len is the length of the longest valid subsequence ending at index I, and then prev right here, prev is going to be the index of the previous word in that subsequence. Now we need to build up our dynamic programming array. So for that, we're going to come underneath this and we're going to say for I in 1 dot dot less than, so 1 up to n, then we open up the brackets. Then we're going to say for j in 0 dot dot less than up to I, we're going to open up the brackets. Now we need to check the conditions. Remember the 3 rules. We need to make sure groups have we have to make sure the groups don't equal each other. We have to make sure the length of the words are the same, and we have to make sure that the Hamming distance is 1. So for that, we are going to say if groups square bracket I does not equal groups square bracket J, that's going to be, this should be a square bracket J, that's going to handle our first rule to make sure that the groups do not equal, the elements in groups are not equal to each other. Then we need to make sure that the Hamming difference is 1, so we can say and, two and signs. We're going to use the function we just created. We're going to say ham, open up the parentheses, I, comma, j, come outside the parentheses, is equal to 1. That's going to make sure our Hamming distance is 1. Then we're going to make sure the length is the same, so we're going to say and, two and signs, dp square bracket I dot len is less than or equal to dp square bracket j dot len. Boom. Then we're going to open up the brackets, and we are going to update our dynamic programming array with the longer subsequence ending at I. So for that, we can just say dp square bracket I equals, open up the parentheses, dp square bracket j dot len plus 1 comma j. Boom, just like that. Now we need to find the index with the longest subsequence. So for that, we're going to come outside of this for loop, declare a variable called idx, set that equal to dp dot enumerated. So enumerated is going to get us the element and the index of that element. We're going to put parentheses, then we're going to say dot max, open up the parentheses, by, colon, open up the brackets, we're going to say $0 dot element dot len is less than $1 dot element dot len. Then we're going to come outside of the bracket and the parentheses. We're going to say exclamation point. Then we're going to say dot offset. Boom. Then we're going to come underneath that. We're going to declare a variable called ands, and this is where we're going to store our answer or our output. We're going to set that equal to an array of strings. Come outside the square brackets and put the parentheses. Then we're going to reconstruct the subsequence by backtracking from the best end index. So for that, we're going to come right here. We're going to say while idx does not equal -1. We're going to open up the brackets, and we're going to say ands dot append, open up the parentheses, word square bracket idx. Then we're going to come underneath that, and we're going to say idx equals dp square bracket idx, come outside the square bracket, say dot prev. We're not done yet, but we're almost there because we still need to return our result. So for that, we need to reverse it before we return it. So for that, we're going to say return ands dot reversed and put 2 parentheses at the end. Woo! I know that was a lot, y'all, but we got through it. That's all she wrote. Let's go ahead and give it a run before we submit it, though. Make sure it's running properly. Okay. So we got an error. Let's see what it says. It says, oh no, expected. Let's see where is that it? Oh no, that shouldn't be it. I don't think that's it, but I had to try it. So, Eric's. So what? Let's see, y'all. Let's see. So we got that. Then we have that. Oh, equal white space, y'all. Equal white space. Let's go ahead and run it again now. See what happens. Okay. Extra argument and call. Oh, sorry, y'all. This square bracket should end right here. Now let's run it again. See if that works. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Look at that, y'all. 7 milliseconds beats 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, I hope y'all learned something today. Before we leave, make sure you get one more look at the code. That's the top part of the code. That's the bottom part of the code. And yeah, hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.